Hello everyone, this is Universo, the place you learn about the entire universe, how it began, and how it will end. Today, we are going to be talking about theoretical and real-world applications of scientific and mathematical topics. I hope you enjoy this informative video. So just to start out, as you may know, science and math are integral parts of our modern-day world and in our lives, and their applications are only growing greater as time goes on. But how, you may ask, and why do these apply to your life specifically as an individual? And more specifically, how have these changed throughout history? Now, throughout history, science and math has impacted a variety of fields. But the ones that we're going to be including in this video are going to be quantum computing, astronomy, and general physics. The reason why is because, one, those topics intrigue me the most, and also those things are the ones that have been impacted most recently. So, with that, let's get to it. So the most elementary point of the matter is going to be in quantum computing, which has been a booming industry for the past few decades, and so has applications to the real world and even to your personal life itself. But more on that, it has significant influence on the world of science and mathematics. One example of such real-world applications concerning quantum computing is going to be how it can hold substantially more information than an average or conventional computer can. Now, computers, they have changed throughout time, as you probably have known. I mean, think about it. I'm videotaping off of one right now. So, or for instance, here, let me go get it real quick. Computers used to have been this big. This is an 1800s adding machine right here. Okay, and then this technology was originally created by Pascal when he created the Pascaline. And then it evolved into the so-called modern-day adding machine, when it became booming throughout the early 1900s and mid-1800s as well. So, again, those have changed substantially throughout history, how we've gone from such a large machine to such a compact machine. Now, one key point that we've noticed throughout time is that computers are getting smaller and smaller and smaller. And that they've gone from those behemoths of machines to computers the size of houses to these computers that we have nowadays. And now we have computers the size of coffee cups, or our quantum computers. Now, the interesting property about these quantum computers, getting more onto that, is that quantum computers could provide a boost to machine learning, and that they can allow for nearly flawless handwriting recognition or the helping of self-driving cars. Think about it. Those things could be applied to your individual lives very, very soon. And that's by being able to account for so many different things all at once in such a small space, that these things could be implemented everywhere, really. And that's their applications are really limitless when you think about it. And that, or for instance, another application of quantum computing is going to be in the field of molecular synthesis and the proper simulation of molecule models and quantum physics. Or in a nutshell, it's going to be simulating quantum physics with quantum physics. Now, the way that these could be applied to your life personally is going to be by being able to simulate molecules and other aspects of quantum mechanics using quantum mechanics. They can be used to make better materials, which those can not only can be applied to manufacture stronger things, say for instance, like in stronger cars, in order to prevent car crashes a little easier. Well, in order to make car crashes go a little easier. They also could open up for more jobs as well, which could apply to your lives. And to be honest, again, as I said before, applications are truly limitless, you know? And that's, like, again, it's a very interesting topic to think about. Now, of course, the theoretical applications, those are going to be a little bit hard to explain, so not exactly I'm going to be explaining them in this video, of course. But I'll be sure to make a future video on that, because I don't exactly have much time right now. So yeah, so in conclusion, quantum computers, they have many applications spreading out over several different fields that could be essential to our everyday lives, that could be essential to our everyday lives in the near future, and in current work in the quantum world. But however, everything has limits, and we can only do so much in the quantum world. It's always going to be a small sliver of reality, in a sense. And in order to break through that fog that is clouding our vision in our research, in order to find out more about ourselves, we must look outwards to the stars, and beyond, as that is our own true home in the universe. So, astronomy has been an extremely important tool that has revolutionized the way that we see and perceive our world. Like, you know, like with the invention of the telescopes and being able to bring faraway objects closer, or in, say, the ability to make horoscopes, say, for instance, and being able to shape modern day culture. Like, there are several different aspects of astronomy that many of us don't even realize, or even in the birthplace of mathematics and calculations, going back to tens or even thousands of years ago. And that without it, mathematics, it might have been set back tens or even hundreds or even thousands of years. Like, it's insane, you know? So yeah. One way that astronomy it could be implemented into your life personally is going to be in one way they actually might not have expected, actually, which is going to be in cell phone communication, actually. And the weird part about that is like how it originated, which is like I'm in the form of radio telescopes. Since radio telescopes, of course, they originally were used in like the Cold War. Sorry, not in the Cold War. Radio telescopes were used for seeing outside, in a sense, like seeing into star systems far away from us. Say, for instance, with the Arecibo telescope, which was made in the 1930s. Those were meant for extraterrestrial communication, actually. However, but now it has been implemented into our own communications in the form of radio receivers that are going to be inside our phones. And as you can see, there's going to be the same recurring pattern as it was with computers. Technologies are getting smaller and smaller and smaller over time. And with that, their applications are becoming more flexible in a sense. So yeah, so it's rather interesting. However, you're probably wondering though, like, well, if that's going to be the birthplace of phones, then what's going to be the birthplace of radio telescopes? Well, that actually is going to be in things like the telegraphs. Telegraphs are going to be ways of transmitting Morse code, in a sense, as you probably know. And those transmit radio signals across oceans, stuff like that. Which, of course, one of the first messages was going to be which means SOS, as it was transmitted over the sea. However, but then, as it turns out, that's going to be what's perceived as the first message. The first message was a single letter, actually, over the Pacific Ocean, which actually is rather interesting. But it shows you just how far that we've gone throughout this. But then you probably are wondering, well, then what's going to be the origins of these? Well, good old pen and paper. And things like typewriters. Like, I have one right here. Yeah, so this is a Remington 3B from 1935. And, of course, this isn't going to be like the origins of, the entire origins of radio communication and stuff like that. However, but it's a good example of it, you know? Since, all of that originated from somewhere. Everything can be broken down into smaller and smaller constituents. And that's the beautiful thing about these topics, And that their applications, as I said before, are only growing over time. And that it's truly beautiful, when you think about it, that we're able to be so gifted with all this technology. And I'm just really overjoyed by it, to be honest. That I'm able to have all these all these opportunities, that we are able to have all these opportunities in a sense, to be able to communicate, to be able to perceive the world, to be able to grow upon past knowledge in a way that is unparalleled to any way that we have ever seen before. And that it's truly fascinating in a sense, So yeah, so in a nutshell, well, to sum that up, astronomy has had many ways of expressing its importance in our daily lives, and that it's only growing as time goes on. I mean, come on, I can go on forever on ways that astronomy could express itself in our lives. But again, we don't have much time in this video, so I'll save that for another time. But there is one crucial point that you might have noticed that I might have ignored due to how general it is in the field of astronomy, and that is general physics, which is literally the backbone of everything in the universe as we know it. So physics has had many implementations into the real world, and its only intent is to derive everything in the real world mathematically. Everything can be derived from something, being that with biology and in classes, to sociology being just applied psychology, and so on and so forth. Every topic, every construct that you could ever think of could be derived into smaller topics. And physics is applied mathematics. Everything can be applied, everything can be derived. And that's the beautiful thing about it. And that's not only that, but due to this, there's going to be several applications that they're not only going to be general, but also specific to your specific needs in your life. So a rudimentary support to this argument is going to be how often it appears in our lives. There's physics all around us right now when you think about it. From you being able to view me on the screen, to the sodium reacting inside of this jar, to the sodium oxidizing slowly inside of this vial of sodium, which is going to be encased in mineral oil in order to prevent it from oxidizing quicker. So again, physics is all around us when you think about it. Rather if it is chemistry, rather if it's just me moving around the room, rather if it's psychology, anything can have physics in it. Yeah, and due to this, us being the clever humans that we are, we've been able to create machines in a sense in order to help us move around in this world. Being able to interact with this world in new and unparalleled ways that we have never seen before. And even the most complex machines, they can be broken down into simpler and simpler and simpler machines. As I said before, everything can be broken down. And elementary machines are known as simple machines. As simple as they are surprisingly interesting when it comes to the physics side of things, when I think about it, Since, physics, it can be applied into anything when you think about it, I know I've said this a lot of times before, but it really is fascinating, And that everything that I have said in this presentation up until now has been derived from physics. And that physics is booming in a sense, there have been so many new discoveries made in this field of physics, made in all the fields of physics, to help us understand our world better. Since science is all about questioning the world around you, It's all about skeptically interrogating the universe, in a sense, or at least as Carl Sagan would put it. But by gaining more insight into our universe and the way that we perceive things, we're able to, in a sense, generalize and understand ourselves better, you know? Since the more you can understand about yourself, the more that we understand about ourselves as a whole, as a unit, as a society, as a globe. We can fix ourselves. We can make this world a better place. And that starts with you. You as the viewer. You can make this world better to your own need. You can help. You can subscribe to things. Like, there's so many ways like that everyone in this world could, in a sense, help, you know? And that by doing that, we can survive better as a race, you know? And that we won't only make ourselves survive, but we can make other beings on this earth survive and flourish. As Carl Sagan once said, our obligation to survive and flourish is owed not just to ourselves, but also to that of the cosmos, ancient and vast, from which we spring. Now, basically, is like, what that means is like, we must not only just like deduct ourselves to our own understanding of this universe, you know? And that we must care about our universe itself, because without it, all of us alive today owe our very existence to it, you know? And that it really is beautiful, you know? That there are patterns that are just repeating everywhere in the universe. We are all just, like, for all we know, like, we are those patterns. But that basically, like, in a nutshell, that basically is like what physics and everything in these universe is. It's just one big pattern that we're just trying to just decipher. It's just one big code. And that by being able to decipher that code, we can hope to understand, as I said before. And again, again, like, there's so many more things to say about this, but sadly, that's all I can say right now. But all I can say is, it's like, that's, you can contribute to, like, being able to understand your universe and being able to, like, contribute to scientific research by signing up to clubs, by making, like, your own discoveries, by analyzing data. Like, there are so many ways like that you as a person could do it. And being able to contribute to science. And that not only helps you, but it helps us. It helps the human race. All right. Well, that is all I have today for you guys about scientific and mathematical applications and real-world applications, mostly. Since, of course, like, quantum computing, of course, is going to be mostly theoretical as far as we know, since we don't exactly know much about quantum computing, as it is quite a new topic. But, yeah, getting off of that, just, all I can say is, just, like, learn. Not only from this video, but from elsewhere as well. Like, the more we know, the more, as I said before, we can know about this world. Like, the more like that I know about this world, the more that we can help ourselves and others. And that's, when you think about it, that really is the only point to life, you know? It's like, if you have some sort of impact to others, being able to help out in other people's lives, being able to make an influence to other people's lives, that is the true meaning of life, right there. But of course, you make your own meaning, but that's a generalized meaning right there. I can't tell you what the meaning of life is, of course. Besides, that'd be getting down an entire philosophical rabbit hole right there. And so, with that, I wish you all a good day. And see you later.